1-3 is about properties of numbers. You're going to recognize the properties of equality and identity. We're also going to recognize the commutative and associative properties. We've talked about these a little bit on and off even this year, but we certainly did last year and the year before. So Natalie lives 32 miles away from the mall. The distance from her house to the mall is the same distance as the distance from the mall to her house. So say the distance is 32 miles to go from the mall to her house, right? Well, it's exactly the same distance to go to the house to the mall. So this is an example of reflexive property when it is true either way you're going, right? It's true if it's the same distance coming or going. So that's the kind of thing we're going to be talking about today. Here are your vocabulary words for the day. New vocabulary. We have equivalent expressions, additive identity, multiplicative inverse, and reciprocal. You guys, we've even had some of these on our last test, so you should be very comfortable with either just writing these definitions down in your notes or looking them up in the glossary if you need to do so. And if you'll take a minute, pause this video, do that now, and then start the video back up. Equivalent expressions represent the same number. So let's remember that 4k plus 8k and 12k, they're equivalent expressions. They both mean the same thing. They're the same amount of something, right? So they're an equivalent expression. Properties I had given you in class yesterday, or the day before, whichever day that was, a handout on colored paper of a chart that has all the properties on it. I would like you to fill this chart out as we go through the video today. And I want you to do that neatly so that you have that as a resource for doing our classwork tomorrow in class. All right? So get out that handout I gave you, that chart I gave you to fill in, and we'll do that together right now. So the reflexive property we just talked about is any quality that's equal to itself. So if you're given the A, and so under symbols you write given A equals B. And numerical examples would be 5 equals 5 or 4 plus 7 equals 4 plus 7. The symmetric property states that if one quantity equals another quantity, then the second quantity equals the first. You know what? Rather than me writing these down, I'm going to let you get the word information out of the textbook. That way it'll be a little more efficient. You can see it and copy it in to all of these blanks. I'll just give you the symbol and the number examples for that, okay? So symmetric property says that so one quantity equals a second quantity. Then the second quantity must equal the first quantity. So for instance, if you had given A and B, right? That tells you that if A equals B, then B must also equal A. So for example, if we know 8 equals 2 plus 6, we also know that 2 plus 6 equals 8. Fascinating stuff, isn't it, guys? So it's symmetrical, right? What happens on one side is also true on the other side. Transitive property says that if you have one quantity and it equals a second quantity, and then if the second quantity equals the third quantity, then the first and the third are also equal. Let's see what that looks like in letters. So if you have A, B, and C, okay, and A equals B, and you know B equals C, then you can surmise, or here, I'm going to show you a little shorthand for therefore. Therefore, can you see that a dot like this, 3 triangles? Therefore, we know that A also must equal C. If A equals B and B equals C, then A must equal C. What does that mean? So for instance, let's look at it in terms of a number. if you know that uh, um, 1 plus 4 equals 2 plus 3, right? And you know that 1 plus 4 equals 5, then you know that 2 plus 3 must also equal 5. If 1 plus 4 equals 2 plus 3, you could be able to substitute 2 plus 3 into here and say that it equals 5. That's the transitive property, where you can transfer it from one equation to the next. Substitution says a quantity can be substituted if it's equal to something else in the expression. So if A equals B, then A may be replaced by B in any expression. Then you can substitute, if A equals B, then you can substitute B for A any place in the expression. So for instance, let me move this guy if I can. There we go. So for instance, if n equals 11, and I have the expression 4n equals 4 times 11, I can substitute the 11 for the n and say 4 times 11 equals 4 times 11. All right, let's see if I can extend my page a little bit here. Bear with me just a second. And we can get down to these addition properties. Okay, these are addition properties. Additive identity. We've done this before. The additive identity says that any number and 0 is equal to that number. So if you have the number A plus 0 will equal the identical number A. So 1 plus 0 equals 1. Additive inverse property says that a number and its opposite are additive inverses of each other if they equal 0. So A plus negative A equals 0, right? 1 plus negative 1 equals 0. That's what an additive inverse property is. All right, lots of properties today, guys. We're just going to crank through them. Let's see if I can get this to move on. Just stop the video anytime. You're going to have to stop the video to put your words in with each of these. So I assume you'll be pausing this video frequently. Multiplication properties. Most of these you guys already know as well. Multiplication property, the multiplicative identity says A times 1 is equal to that number. So if we have 7 times 1, it equals 7. That's a multiplicative identity. Multiplicative property of 0 says any number A times 0 equals 0. So 8 times 0 equals 0. Any number times 0 equals 0. And lastly, we have the multiplicative inverse. For every number A over B, and B does not equal 0, there's exactly one number that when you multiply it by it, you will get 0. So A over B times its multiplicative inverse, B over A equals 1. 7 over 1 times 1 over 7 equals 1. Multiplicative inverse. This should feel a lot like, oh yeah, I've seen that before, I know that. Okay, let's look at this study tip for a minute. As you evaluate expressions, you're really constructing an argument using stated assumptions or definitions. And these are these properties that we've been already talking about. The properties that we've just talked about, the property of numbers, are valid reasons for making your argument. So when we're going to start thinking about, we always do these steps of algebra. We're going to try in this chapter to actually justify how we do that, why we can do that. What's the rule that says we can make the next step in algebra? And you'll see how this works in a minute. And this is the basis for geometric proofs, for proofs in geometry that you'll be doing next year. But we're going to do it with algebraic proofs. So I just read what I said. Geometric proofs are a constructed argument for reasoning why a theorem is true. And in science, when you write a scientific thesis, you have to construct an argument for why this is true. And so in math, we're going to do the same thing. We're going to construct an explanation to explain how we get from point A to point B. All right, so for instance, here we have an equation, an expression. Evaluate 7 parentheses 4 minus 3 and parentheses minus 1 plus 5 times 1/5. And what we're going to do is we're going to solve it on the one side, right? On the right-hand side, we're going to evaluate it. And on this side, we're going to name each property that's used. And what I think would be best for you to do is to first do the right-hand side. Evaluate the expression first, and then let's go back and look at which properties are used, okay? So we have our expression, 7 parentheses 4 minus 3 minus 1 plus 5 times 1/5. Okay, so 4 minus 3 is 1. So we have 7 times 1 now, minus 1 plus 5 times 1/5. Then what's the next thing we can do? What's the next thing we should do is do our multiplier 7 times our 1, and we get 7 minus 1 plus 5 times 1/5. Then the next step, we're going to multiply 5 times 1/5, so we'll get 7 minus 1 plus 1. And that next step, 7 minus 1 is 6, plus 1 is 7. All right, now let's look at what property we use to do it each step. How did we get from here to here? What did we do? Well, we substituted a 4 minus 3 equals 1, didn't we? So where there was 4 minus 3, we substituted in and put a 1. What did we do in the next step? In the next step, 7 minus 1, so we took the 7 times 1 and changed it to just a 7. What property is that? That's the multiplicative identity property, right? 7 times 1 is the same as 7. Then we used the multiplicative inverse property when we did 5 times 1 over 5 is 1. And then we substituted. 7 minus 1 is the same as 6. And so 7 minus 1, we substituted in a 6. And finally, we substituted again where we put 6 plus 1 is the same as 7. And that's how we justified in steps each step of our evaluating our our numerical expression. Okay, shall we try another one, guys? Let's try it. Name the property used in each step. So they've given us the steps in this problem, and we just have to substitute in the properties. Okay, so 2 times 3 plus parentheses 4 times 2 minus 8. So we have to do what's inside the parentheses first, and we take that 4 times 2 and change it to an 8. So what property is that? We're taking 4 times 2, and we said it equals 8. And we put an 8 in there, so that is substitution. And then what did we do? We did 8 minus 8. What property is 8 minus 8 equal to 0? When is 8 minus 8 equal to 0? That is the additive inverse, right? We're adding the opposite and we get 0. And then we did 2 times 3. So what do we do here? We substituted again, right? We substituted the value of 2 times 3, which is 6, into the next line of the expression. And then we had 6 plus 0 equals 6. What property is that? That's the additive identity. And I don't mind if you abbreviate, sort of like I'm doing here on these problems. Shall we try one more? Okay, let's do 7 parentheses 7 times 1/7 plus 6 parentheses 15 divided by 3 minus 5. So first thing we're going to do is go inside the parentheses and substitute 15 divided by 3 for the 5. 15 divided by 3 is 5. And what we've done, we've substituted, right? What's the next thing we do here? We're going to take 5 minus 5 and change it to 0. 5 minus 5 is what? It is the additive inverse. And now 7 times 1 is 7. 7 times 1 over 7 is the multiplicative inverse, right? That's a property in that step. And then 1 plus 6 times 0 is the additive, multiplicative, what is it? Property of 0. Because 6 times any number is 0. And then 1 plus 0 is additive identity. 1 plus 0 equals 1. Okay. So now we're taking properties and actually seeing how we're using them. All right, commutative property. So the distance from Nikki's house to school is 2 plus 4 miles. And the distance from school to Nikki's house is 4 plus 2. So we talked about the commutative property. We talked about it yesterday, the other day in class when Miss Creighton was in here. 2 plus 4 is the same as 4 plus 2. That means you can move the numbers from one place to the other and you still get the same amount. So if you have the, and you can write this down in your chart, right? Here are the words. Here are the symbols. If you have A and B, A plus B is the same as B plus A. And it's true for multiplication too. A times B is the same as B times A. And here are some number examples that you could put in your chart as well. And it looks like if you're in your textbook, you even have a little video you could go watch all about it. Associative property. That is when you hang out with your friends. Who are you grouping with? What group do you belong or associate with? So the associative property, when you're adding or multiplying, it doesn't change the answer. So if you have parentheses, A plus B and parentheses plus C is the same as putting the parentheses here and leaving the A outside, A plus B plus C. And that's also true for multiplication. If I have 2 times 6 in parentheses times 9, it's the same as 2 times parentheses 6 plus 9. That's the associative property. It's the one where it uses the parentheses. So here we are planning our little party. Eric makes a list of items he needs to buy for party and their cost. Find the total cost of these items. So we have balloons for $6.75. We have decorations for $14. We have food for $23.25. And we have beverages for $20.50. All right. What's the total cost? Well, he's going to try and actually do this in his head if he can, I think. So he's going to group it. He's going to put it in a different order so it's easier to add. So what he does is he takes the 675 and puts it here and the 2325 and puts it here. And then he takes these two and puts them together. Why does he do that? Because he knows to add 675 plus 2325 he can do in his head. 75 and 25 is going to be $1, so that's going to be $24 now, plus the 6 makes 30. And it's very easy to add 14 and 2050, you get 3450, and then you can add 30 and 3450 in your head and get 6450. Properties that he's used is first he put it in a different order. He used the commutative property. Then he grouped them, used the associative property, and then he substituted and substituted. Okay. The next thing we're going to talk about is using multiplication properties. Let's look at an example here. So if you have to evaluate 5 times 7 times 4 times 2 using properties and numbers, name each property used in each step. So I have 5 times 7 times 4 times 2. Well, it might be easier for me to multiply 5 and 2 together than it is 5 times 7 times 4 times this. So let's group it to make it easier in our head, because we know 5 times 2 is 10. And then it's always easy to multiply any number by 10 because you're just going to add a 0. So that's why we've grouped it this way. 7 times 4 is 28, times 10 is 280. All right? So we can look at one of these problems at the bottom here. And I'm thinking, let's look at this one just to shorten this lesson a little bit for you. I'm going to regroup. I'm going to use the commutative property of multiplication, and I'm going to go 5/3 times 3, which is the same as 3 over 1, times 25 times 2. Well, 25 times 2 I know is 50. And look at here, I can cancel those guys out, and 5 over 1 is the same as 5. So my answer is 250. That made that problem really simple, didn't it, compared to how it was? Do y'all see what I did there? You want me to do that again? I took the 5 over 3, and I put it next to the 3 right now so I could multiply those two together. And I made those, and I should have said I used the associative property to do that. So 5 over, and then I multiplied 25 times 2. I grouped them this way to make it easier on myself. 25 times 2 is 50. I'm going to substitute that. Those two cancel each other. 5 over 1 is the same as 5. And now I can multiply that pretty easily. All right. Here is your practice for tonight. Problems 1 through 8. We will put these on the board tomorrow, so be thinking which one of you guys would like to do which problem. And good luck with this.